Children are born curious explorers of the reality that surrounds them. It's important that they meet adults on their path who support their natural inclinations by creating rich and interesting environments for experience. If this happens, spontaneity transforms itself into skills that lay the foundations for future learning. National guidelines for nursery schools indicate that the child should explore reality and reflect on experiences by representing and reorganizing them, researching objects and natural phenomena, and thus developing an initial physical organization of the external world. The European guidelines also underline how important it is to bring boys and girls closer to STEAM subjects, to develop key skills that prepare them for the challenges of the future, taking into account links with arts, creativity and innovation. We would say with the 100 languages in dialogue with scientific disciplines. In practice, this means that boys and girls need daily actions and situations that broaden their possibilities, starting from their daily life knowledge, developing their skills and heightening their awareness in the scientific field. For this reason, the new learning environment called eVolcani was designed under the Learning by Languages brand to bring children in the 3 to 10 age group closer to science, training them in research and exploration through paths and contexts studied ad hoc. In fact, spontaneous experience is not enough, but ecologically rich contexts are required so as to orient and focus the attention and research of children. Boys and girls do not suddenly discover themselves as scientists in middle or high school, but they can progressively mature the prerequisites and alphabets that will allow them to approach scientific disciplines in subsequent years, if they have had significant learning opportunities in early childhood. The eVolcani project saw the participation of a research group made up of pedagogues, atelierists, university researchers, designers, and representatives of the educational world. This is the characteristic of the Learning by Languages method, which feeds itself on research applied to educational contexts, enriching itself with a multidisciplinary perspective.
The team of researchers at the University of Trieste have recognized the ability to follow the complexity of educational processes in infant-toddler centers and preschools that follow the Learning by Languages method, especially on the issues of design, documentation, and innovation. In addition, the method focuses on the educational environment that needs to be thought about and which progressively evolves towards learning. Learning by Languages emphasizes the abilities of all boys and girls to develop their exploration, reasoning, and communication skills in all symbolic systems, including the scientific field. The work of the research team of the University of Trieste in the eVolcani project has found a strong synergy in the individuation of a conceptual reference framework for knowledge, in particular with the theories of Vygotsky and the zone of proximal development, of Brunner and with scaffolding, and with the most recent theories of the development of infantile thought, such as Alison Gopnik and Frank Kyle, which tell us precisely how children have intuitive theories of the physical and living world. However, that development occurs when the learning environments are structured in such a way as to guarantee continuity of experiences, dialogue in order to share observations, compare ideas, and elaborate explanations.
With eVolcani, we can create a learning space at kindergartens and a place to encourage boys and girls to apply themselves to learning science, to make them reflect, support them in comparison, and to accompany them in the search for new information, as such welcoming their different ideas, comparing them to seek new explanations on the different fields explored. eVolcani have therefore become experimental sets for children for research, so as, for example, to investigate certain topics like air, water, earth and fire. During the experience, the children told us that the fire burns, which turns black, but is also a bit blue, a bit red, and a bit orange, that it smells of smoke and fire, and it has such a shape, a leaf that you can even draw it. The researches made by the children are intertwined with different languages: graphic, writing and logical mathematical, thus becoming traces that inhabit I Vulcani. Children study concepts such as chromaticity, beauty, texture, shape, micro-macro, light and temperature. The vertical perspective and the aesthetic dimension of the volcano fascinate children. The different floors also allow light gameplay, perspectives below and above, thus training their different views. About fire, for example, they told us that it goes up there, towards the light, that it goes up and down, but that you can also trap it in a glass jar.
These are microarchitectures with totemic presence on wheels. What you see here is quite precisely the model in scale that is produced in the laboratory and represents the first idea I shared with the working group, with whom we are now perfecting and improving the model to create the full-scale prototype. Volcanoes are workshops that invite children to gather all around, like a kind of big hug, to better develop their skills of scientific thinking. The investigation does not take place horizontally, as we are used to at desks, but rather with a different outlook that allows one to observe the phenomena related to the four elements. These are the elements that Pericles had already indicated as the roots of science, namely water, earth, fire and air. And this project allows us to observe these elements during their transformations, through the phenomena they represent, then vertically through a dimension from above and below, and from near and far. Our comprehensive institute carries out 4 multidisciplinary and curricular STEAM learning paths for the 3 to 14-year age group, represented through 4 female figures. These are STEAM's sisters. Lucy addresses artificial intelligence, Mary, learning to learn, Frida, creative intelligence, and Maya, plant intelligence. Within this context, through Maya, the Institute participated in the research group on iVolcanoes, a learning environment for STEAM, looking at didactic experimentation. iVolcanoes, an innovative learning environment, is part of a project of renovation of the kindergarten and primary school, aimed at supporting the laboratory learning of children and innovative teaching tools for educators. This learning environment is essential to accompany educators in the renewal of teaching and learning styles, making it easier for boys and girls to learn scientific disciplines and thus giving them improved opportunities for their future.